Hello, I'm Emma Irwin, a solution engineer with Dataiku, and today I'm here to walk you through our flagship product called Data Science Studio, sometimes known as DSS. It's a collaborative data science software platform for teams of data scientists, data analysts, and engineers to explore, prototype, build, and deliver their own data products more efficiently. At a sort of high level, Dataiku supports integrated documentation and knowledge sharing, change management, and team monitoring for your data science projects. Within the tool, you can clean and enrich data interactively, perform visual data transformations, use integrated advanced processors, and it allows you to use the visual UI or code to leverage the latest ML technologies, our built-in auto machine learning capabilities, and provides access to deep learning at your fingertips, with support for Keras, TensorFlow, and our pre-trained models right from the Dataiku interface. Don't take my word for it, though. If you like what you see later in the demo, you can get a free version of the software right on our website at www.dataiku.com, or request a personalized demonstration with someone from my team and learn how to use Dataiku for your specific use cases and in your specific environment. With that being said, a couple of slides before we dive in. This one here shows some of the many technologies that we support in the platform. All of the major coding languages for data analytics and data science, like you can see here, Python, R, SQL, and more. New and old infrastructure, like various Hadoop distributions, on-premise and cloud databases, and some cloud-only object stores. And this idea of supporting a wide variety of storage and processing technologies is one of the key tenets or capabilities of our platform and our company, because we ultimately want to eliminate the fear of migration or the worry about lock-in and let you focus more on the data projects themselves. Then, of course, whenever necessary, you can also extend the capabilities of our platform with a full ecosystem of solutions for our particular needs, things like visualization tools such as Tableau, Power BI, AI, and more, and a whole host of plugins that we build and our customers also build and expose to the rest of the ecosystem. With that being said, Dataiku is truly an end-to-end platform solution. It supports users of all skill sets in building out data projects in our what we call flow, so what you're seeing on the screen now. And it allows users to catalog and connect to various data sources, prepare, enrich, and clean that data, apply machine learning techniques and build models, which can eventually be put into production. And all of these capabilities are possible either through code or through point and click operations on the screen, which is how we describe ourselves as being skill agnostic. Really, any skills you currently have, you can bring to the table and as well develop or learn new skills once you're within the tool. And so with that, let's swap over to the tool itself. We're starting on the homepage. Dataiku is a server-based tool, but as you can see, users gain access from their favorite browser. So here I'm using Chrome, and we're looking at my team's design environment. You can see there's a variety of projects at the top, as well as some dashboards you can click into for actionable insights, and then wikis where I could add additional information. Down here at the bottom, I have the option to onboard or upskill with tutorials and documentation. And up here in the corner, where you see what I call the waffle menu, more options, ways to browse through the different assets in the tool, to access those plugins I mentioned, or craft or code your own. An administration panel for configuring your instance settings, which we'll get into in a little bit, as well as a catalog that allows you to search across all of the projects and all of the data sources within the entire platform. So from there, we can jump into first a blank project. I've labeled this one AI Forum Demo. If we go in here, we can see that we have a title, a subtitle, an area to create a wiki that can be edited at any time using some regular options here. A to-do list that lets us know what we still have to do to accomplish our data project, as well as a timeline of all of the changes that have been made in the project. And this is sort of the central location to viewing information that relates to this specific data project at any one time. But when we actually begin to work on it, we're going to want to go to our flow which is currently empty. So it starts empty, but eventually this will show the end-to-end project as we work on it. And what you'll see, this is sort of an image. Blue squares will eventually represent data sets. Yellow circles will represent visual transformations, and orange circles will represent code recipes, which is to say code that's been written in the tool or externally that is applying to the data sets within Dataiku. Eventually, we'll get to the part where green icons represent machine learning models, but that's yet to come. There are many possibilities for Dataiku to connect to your data sets or import them, which you can see here. Things in your file system, on the network, in traditional relational databases, or in cloud storage, as well as NoSQL or other. And Dataiku allows you to work with data that's structured or unstructured. So structured meaning series of records with the same schema, which we call a data set, or unstructured that may have an internal structure, but the entries do not necessarily have the same schema of any sort. So like images, video, audio, and so forth. Now, what I'll do first before importing an actual data set is go back to that waffle menu I mentioned previously, come into administration, and you'll see that I have this tab called connections, which I can click into and manage all of the connections for my entire platform from one location. I could create a new connection to, like I said, databases, file-based cloud storage, or more. Or I can update or change or view the settings, for example, with my Amazon S3 bucket. Here I've chosen to use the key pair and point to a specific bucket. And when I test that, I can see my connection's okay, and that it's actually pointing towards this bucket I created for this specific demo, which just has one CSV inside of it. If I go back to that menu, I can see I also have a Snowflake connection set up. This is pointing to a specific database warehouse and requires a user or role. In my case, as the individual who created it, I'm the sysadmin, but I can view that over here. We'll give it a second to reload. And you can see I have my list of databases. SFTuts is the one I've connected to, and here are the tables. It's really simple to set these up once and to manage them from a single location. And this way you know that your connections are always up to date and that your individual users are accessing the same data sets that everyone else is, and that your analysis and your final outputs will be related to the same types of data. So you can also just quickly notice I do have a PostgreSQL and then the file system, of course, because ultimately what we want to be able to do is read and write from these different data sources, execute in a database SQL recipes, or perform SQL queries against it, use them as live engines if they're both compute, or just access the data. And when I go back to the flow now, which I'll click into from here, it'll give me the option to import my first data set. And I will first connect to my S3 bucket. So go in here, you can see that I'm using Emma's S3. The path in the bucket, if I knew it off the top of my head, I could use, or in this case, I'll browse. And you can see that one CSV that we mentioned before. Click OK, and we'll wait while that imports. Notice this was found. And if I want to change the dataset name, I can do that here. So I'll just name this Cal for calendar and click Create. Once it's done, it's giving me the option to explore the data as said by this tab, which is to say it's showing me a set or sample of the data in a format that's similar to what I might see in Excel spreadsheet, something that's really simple for the human mind to comprehend. I can configure this sample that I'm looking at any time, but for now, perhaps I'm just interested in a random number of records, maybe just 1,000 of them, save and refresh, and this will update for me. In addition, so we'll see that that's now popped up. This is on our flow, and we can add a few more. I'll add one from the network. So I have another data set here called listings. It's being held at this URL, which I can test. And let's just call this list and create. This one's quite a bit bigger, so a lot more information to comprehend, but don't worry, you don't need to understand it just yet. All we need to know is that now within our flow, we have two data sets, which are actually just basically pointers to that external or source location of the data. So in the one case, the S3, or in the other, the network storage. This is one of the things that makes Dataiku different, is that we are not trying to be an ingestion engine. We don't want to copy or take over large amounts of your data, because that's very time intensive and would cost like double consumption. So rather, what we want to do is be a pointer. In this case, however, maybe I need all of my data to be in that Snowflake database that I mentioned. I can sync it through Dataiku, which is the idea of copying one data set to another. You see it's giving me an option. The dropdown shows the different connections I have set up, and I'll choose Snowflake and create that recipe. Once done, I can run it, and it can run in the background while I go about doing other things. You can see that it is attempting to create it, which is why I have that dotted line, and once it's done, it will be a full-fledged blue square like the rest. I'm going to make this one a Snowflake as well. And the reason for doing this is because once I have centralized my data sets in a single underlying infrastructure, I can actually use that as the sort of push down engine or compute engine for future recipes. Again, that's transformations against the data that I want to complete. And with something like Snowflake, where you're using a really powerful data warehouse, then you'll be getting all of the kind of benefits, like sort of, as their marketing would say, unlimited performance or scale on one platform that is holding one copy of the data for many workloads. So it's really powerful. And here you'll notice, or maybe you haven't, and I'll point it out, at the bottom we have this S3 to Snowflake. This is what we kind of call like a fast path, or a special type of connector. And this is a way that Dataiku is automatically using an optimal S3 to Snowflake. It also works for Azure Blob to Snowflake copy mechanism when you're doing these types of sync. So rather than doing just like a regular insert, this is like a bulk copy, and it makes the process go a lot faster. You can see here that my job succeeded. And if I go over into Snowflake and I look at these tables, I can refresh it, and I should see, we called this one calendar copy. Yes, so calendar copy and then list copy have now appeared. If I wanted to see what that actually looks like for the history, I can view here. These are connected just with a JDBC connector. So it's this commit that we're looking at. Oh, perhaps it's not. It's the one down below it, where we're copying into this AI forum table from S3. So you can see how that's a bulk copy statement versus this one, for example, which is creating a table that represents a calendar copy. So you can always view the underlying SQL, but it is sort of happening there and orchestrated here, if you want to think of orchestration as the best description for how we're doing things. Moving on from there, what we want to do is actually explore what some of this data looks like. So we saw the tabular format before, but what if we click into it and look for a moment at what does this data really look like? So we have an ID, we have a name, a host who's listing this specific rental unit, and then some information like how many reviews they have, etc. And so these are all related to like a housing rental market, all the listings that are available, the prices, the minimum nights. And what we ultimately want to do is be able to predict the price of any one of these units at a specific time. And this like Explore tab lets you get familiar with what some of the features of your data set are, see if there's some missing data. In our case, neighborhood group is missing information, and start to hypothesize how you'll work with the actual data. From there, obviously, we don't just want to make this model off of our one single data set. We want to bring these two together. So I'm going to choose the next visual recipe, which is a join. You see how it automatically chose the one that I had highlighted. And then I'll also choose cal copy. We'll call this full data. And again, storing it into Snowflake. When we create this recipe now, what we're presented with is the option to, instead of writing our own SQL join, do it by a point and click. We're getting the choice of left join, inner join, outer join, etc. Keep left join. Actually, let's do outer join. And then right now, it automatically chose price and minimum nights because that, I suppose, exists in both columns. But instead, what we actually want to do is each has an ID column, ID and listing ID. These are actually the same, so we'll use that for our quality. Click close, view the various columns that are coming with, the output, which will be this, and then the actual query that it will be running, which is a select statement. Here we go, perform this full outer join. Perfect. And when we're ready to run it, notice that I have the run option and I also have in database SQL option. In stream is if we wanted to do it on the server, which we don't. We want to do that in SQL. So we'll click run and we'll let it work. And as the job is running, you'll get this at the bottom, but you can continue working as you see fit, like I mentioned. And from there, we will have one complete data set that we're going to work on and begin to, as it populates, do some additional analysis. So something like charting or statistics are going to be supported from here as well. We can pull in, based on the count of records, something like room type. So it will auto-generate a chart for us. We have two options, entire home or private room. Perhaps we want to view this as a pie chart instead. Or maybe in a different world, it makes sense as a scatter plot to do. And you just pull these over. If you need to create a second one, you can click chart at the bottom. Or if you want to look at some statistics, you just click into the statistics tab, create your first worksheet, choose which type of statistics you want to do. I chose univariate, but there's quite a few others. And we can start to do, let's say, something like number of reviews, minimum nights, reviews per month, and adjusted price. Click the plus sign. It will do some stats over our entire data set with histogram, summary statistics, frequency tables, and more. This will give us a good way of beginning to understand what this data is telling us before we start to make predictions against it. And this is a rather large sample size, so it was just running for a minute, but there we go. You can start seeing the distribution, places that cost $100, 2,600 of them. That's a lot versus 150, 120, etc. In here, reviews per month. We have a huge population of them that don't have any reviews or has nothing recorded, so it's something we want to look at. And again, we can keep on creating these, or if we so choose, we can actually publish these to a dashboard, which is a concept we won't get into a lot today, but eventually does become quite interesting when you start thinking about what types of visualizations or reports or exports you want to make. Now from here, we can't just make a project based on this data as it is. We're going to want to prepare it, and I'll call this full data prep. Once you create it, we're going to have the choice to choose specific columns like, let's say price, because we also have adjusted price, and just fully remove them. That step will be recorded on the left-hand side. And when I click out of it, I'll no longer have that column. Alternatively, something like our adjusted price, perhaps I don't like the fact that it has a $, and I can actually remove or replace that $, because in this case, I know it's a price, I don't need a $. So it tells me what column are we working with. If I want to output it into a different column, I could. In this case, I'll just replace the $sign with nothing, and it will get rid of them all for me. This little helpful hint is telling me to go to the processors library. If I do that, I just add a step. 91 processors are available to me, whole bunch of options. This is maybe if I know that there's something specific I want to do. For example, if I've already created quite a bit of work, but now I want to write a Python function because it's the last thing I need, I can add some code right in here. Or if I am not super adept at using Python myself, but I know that there's a data scientist on my team or a programmer on my team who can help me, they could write something, or they could copy and paste some code that existed in a previous workflow, put it over in here. Easy. I can now use this in this flow, like in this script, or I could also duplicate it with this duplication for a different project in the future if necessary. Don't like it, can get rid of it. Easy. Lots of things you can do. I can start to look at something like maximum nights and maybe process with a formula. So maybe I want to do like if maximum nights greater than 365, just set it to 365. Something like that. And then I'm just basically saying I don't care about anything that's over a year, because what they're really saying is like unlimited number of nights you can stay here. If I'm satisfied with that, I can just click run. It's going to tell me now that my schema is actually different. This is because what I've done is removed at least one column. And so I do want to update that. And it's telling me I can drop and recreate the table. So when I go back into Snowflake in a second, you'll see that there's only that single table there, but it has been updated to this new schema, which is perfect. From there, go back over here and you'll see it's being built. And again, I can just check into what's happening. We are, yes, making changes in here. Why do I care that I can view this? I think it's just important to know that like we're not doing any type of proprietary work. We are really trying to make this an orchestration tool for all possible underlying infrastructure and environments that you may have now or in the future. And I'm actually just going to slip over here to supported connections for more documentation. And what this is showing you is all of the different ways that you can connect to data within Dataiku. So again, DSS. And you can see this list over here is ever growing. Standard formats that we use, Hadoop specific formats, and we do, of course, expose additional plugins for like newer data types or infrastructure. Now, this is building out, and while it's doing that, I'm going to show you the kind of last cool thing for this demo, and that's this lab feature. The lab feature lets you do your own modeling and machine learning right within here. In this case, we want to be doing a prediction algorithm, and the prediction algorithm is going to be on adjusted price. Just want to create a quick prototype today. Click create that. Oh, it's not quite finished building, so just give it 1 second. Let this run. While that's doing it, I'll actually just jump into another project where I can show it off. So you'll see here, I have a data set. I can click into the lab, AutoML, quick prototype, and create. And what we're doing here is automatically generating 2 different algorithms with 3 features. You can train that. You can go into design and set specific metrics that you want to optimize for, features that you want to handle, in this case, rejecting unique IDs. Generate features, if you so choose, is as easy as just clicking yes or no. And then choosing additional algorithms can be handled within the same pane as well. For example, here you are. There you go. Hyperparameters, runtime environment, and waiting strategy, you can adjust to your liking. And last thing in this algorithms tab, if you so chose to write your own custom Python model, you could do that in here using a code sample of ours if you're so interested. And then have that be associated or scored against the sessions that you're running. So you see I have 1 session here, and if I train my second model with those new changes, I now have 4 algorithms. And as those begin to train, they'll be scored against each other based on the metric you've chosen, and from there given a trophy. And ultimately, once that has happened, you can view the differences on this table. So you're not tied to screenshotting work that you've done in your own IDE or saving Jupyter notebooks and hoping not to write over them, or God forbid, writing down on paper and then losing the paper, which was your best model and how. I think that's happened to a lot of people, more than we'd like to admit. But all of it is tracked and held for you forever here. And then if you want to actually view one of these models more in depth, for example, this Ridge L2 regression got the trophy in this case, I can click into it. I can look at some of the interpretation information, like regression coefficients, partial dependence, which can be computed on a specific feature, subpopulation analysis, individual explanation. I can look at performance of the model against the known data set. So this was labeled data. And then I have the model information as well. So a lot of info, and just bringing it back to sort of at the beginning, we looked at a project, it had a name, it had assets, and sort of a goal. These can be arranged in such a way as to access data from sort of any location, run on a multitude of compute, work either through clicking or coding, as we saw, and end up with a product that you may need, whether that's a chart or a report or a model that you expose as an API. And I think that our orchestration capabilities make us extremely unique in this space. So I would love to talk more about the product itself and what we can do for you. If you are interested, again, in that free version, you can find it at www.dataiku.com. And we can, of course, set up a second customized demo for you in the future. Thank you so much for sticking with me. Have a great day.